Hello guys, in this video we are going to talk about quadratic equations. So what is a quadratic equation? Equations with the highest power of variable as 2 are known as quadratic equations. For example, x squared plus x plus 6 is equal to 0. Now here in this equation the highest power of x is 2. So it is a quadratic equation. Now let's talk about the roots of a quadratic equation. Suppose our quadratic equation is something like this: ax squared plus bx plus c is equal to 0. Then, if alpha is a root of the quadratic equation, then we will be having a alpha squared plus b alpha plus c is equal to 0. So, if alpha is a root of the quadratic equation, then it will be satisfying the relation a alpha squared plus b alpha plus c is equal to 0. Now, how to find the roots of the quadratic equation? Now, there are several methods, but first we will consider the factorization method. Now, in this method, suppose we are having our quadratic equation of the form ax squared plus bx plus c is equal to 0. So, we have to find alpha and beta such that alpha plus beta is equal to minus b, while at the same time we should have alpha beta is equal to AC. Here alpha and beta are the roots of the quadratic equation. So basically what we have to do is we have to guess alpha and beta such that alpha plus beta is equal to minus b and alpha into beta is equal to AC. So basically it's a trial and error method where we have to guess the values of alpha and beta, and then we will be putting those values of alpha and beta in the relations alpha plus beta is equal to minus b and alpha into beta is equal to AC, and see whether our guessed values of the alpha and beta are verifying the relations or not. If they verify, then those values of the alpha and beta are the roots of the quadratic equation. Now let's try to understand this. For example, suppose we have a quadratic equation something like this: x squared plus x minus 6 is equal to 0. So here a is equal to 1, b is equal to 1 and c is equal to minus 6. So according to the factorization method, we should have something like this, that is our alpha plus beta is equal to minus b, that is equal to minus 1. And at the same time we should have alpha into beta is equal to AC, that is 1 into minus 6, that is equal to minus 6. So the roots of the quadratic equation x squared plus x minus 6 is equal to 0 should satisfy the following relation, that is alpha plus beta is equal to minus 1 and alpha into beta is equal to minus 6. Let's try 1 and 0. So 1 plus 0 is equal to 1, which is not equal to minus 1. So it cannot be the roots of the quadratic equation. Now let's try 1 and 2. Here 1 plus 2 is equal to 3, which is not equal to minus 1. So once again it is not the root of the quadratic equation. Now suppose let's try 3 and 2. Here we are getting 3 plus 2 is equal to 5, which is once again not equal to minus 1. So it is also not a root of the quadratic equation. Now suppose let's try minus 3 and 2. Here minus 3 plus 2 is equal to minus 1. Okay, first condition is verified. Now let's try with the second condition. Minus 3 into 2 is equal to minus 6. So our second condition is also satisfied. So minus 3 and 2 are the roots of the quadratic equation x squared plus x minus 6 is equal to 0. This is how the factorization method works. But here we have to basically guess alpha and beta, which can be quite tedious. So we need something better and something faster. So here comes our next method of completing squares. Here the name itself says completing squares. So we have to do something with the squares. Now let's try to understand it. Suppose we are considering the previous example once again, that is x squared plus x minus 6 is equal to 0. So we can write it as follows. Basically we are just putting in few brackets. Now we can write it something like this: x squared plus 2 into x into half plus 1 by 2 whole square minus 1 by 2 whole square minus 6 is equal to 0. Here we have basically added half square and then we have subtracted half square. So basically our equation remains same. Now we can simplify it as something like this. Here basically we are using this formula, that is a plus b whole square is equal to a square plus 2ab plus b square. Now we can further simplify it something like this. Here basically we are getting x plus half whole square minus 25 by 4 is equal to 0. Now this can be written as something like this. Here basically we are putting minus 25 by 4 to the right hand side of the equation. Now this can be written as something like this, as 25 by 4 is equal to 5 by 2 whole square. Now we will be basically taking square root on both of these sides. So we are getting something like this, x plus half is equal to plus minus 5 by 2. Now from this we are getting x is equal to minus half plus minus 5 by 2. Now this can be further simplified as x is equal to minus 3 or 2. These are the same roots which we have found using the factorization method. Now we will be moving on to another method which is known as quadratic formula. Now this method is quite straightforward. Basically we will be having a formula and we will be plugging the values of a, b and c, and then we will be getting our roots. So let's get started. Suppose our quadratic equation is something like this, ax square plus bx plus c is equal to 0. So we can write this as follows, that is a into x square plus b by ax plus c by a is equal to 0. Now we can write this as follows, that is we are basically putting a in the denominator, as this is a quadratic equation, so a is not equal to 0, so there is no question of getting undefined on the right hand side. Now we can further write this equation as follows, that is x square plus 2 into b by 2a into x. This is basically same as b by a whole into x, and then we are adding in a term, that is b by 2a whole square minus b by 2a whole square. That is basically we are adding and subtracting same term, so basically we are adding in nothing but 0, and then again we are having plus c by a is equal to 0. Now from this we are having something like this, that is we are basically transferring minus b by 2a whole square plus c by a into the right hand side. Now from this equation we can write it once again as follows. Now we can write this is basically a plus b whole square's formula. Now we can further simplify it as, actually this is the a plus b whole square's formula, and then we will be simplifying it as follows. That is, on the right hand side we are getting b square minus 4ac whole divided by 4a square. Now we will be taking square root on the both sides of the equation. Then we will be getting x plus b by 2a is equal to plus minus square root of b square minus 4ac whole divided by 2a. Now we will be evaluating x, that is x is equal to minus b plus minus square root of b square minus 4ac whole divided by 2a. So we have found out the value of x, that is basically the root of the quadratic equation. Now let's talk about the nature of the roots. That is basically our roots can be real numbers, or maybe our roots are equal, or maybe they are distinct, or maybe there are no real roots. So let's try to understand that. This is our quadratic formula. Here b square minus 4ac is known as discriminant. Now according to the nature of the discriminant we will be determining the nature of the roots. Now suppose b square minus 4ac is greater than 0, then we will be having distinct real roots. Actually this is the case of the example which we have considered. Now it can be b square minus 4ac is equal to 0, then our roots will be real and also they should be equal. Now we may have a case something like this, b square minus 4ac is less than 0, then there will be no real root. Then the roots can only be complex numbers. Thank you for watching.